Hello, it's Duncan. In the last episode, we had the problem of how to check some, but not all, properties of an object in a test. We cobbled something together using the standard JUnit 5 assertAll, but there are other more expressive options available. So today we're going to look at Hamkrest and Strikt. Before we get on with the main business, a couple of things came up in the comments. First was Yantaro Yusong, I probably butchered your name, sorry, points out the standard library has a function very much like the only that we wrote, and it's called single. So this is only, but if we look at single, you can see that does very much the same thing. So I think there's no point in having our own code lying around, so we can refactor by replacing our implementation with single and then inlining only. Run all the tests. Good. That refactor is a tiny bit risky because we know we're only overcalling it with one item, but I don't think that's a high risk given that we looked at the implementations. So let's commit that. We can now delete this file and commit these as replace only with single. Good. David A asked why I repeated the test here for the first item. So we had this duplication here and here. So in this first case, we have one event, and in the second case, we have two events, and we check the first event both times. That's a good question. And to me, it comes down to when we've done different things in the arrange and act, this bit here and this bit here, the part of the test that happens before we do any assertions, who knows what effect they have on the code? I mean, when we wrote it, we knew that we were gaining an additional event, and perhaps it would have been better if we'd said with an additional event. But if we would come to this test in the future, and this wasn't here, then we'd have to notice the difference between this event single and events one, second event, in order to see the difference between the behavior. And if we did notice, we'd still have to guess that the first event was the same as this one. In this case, better to spell it out explicitly so that whoever reads this, even if it's our future selves, doesn't have to read the implementation in order to see what this code does. Let's remind ourselves what we're trying to show with this code. We have a filter, and ordinarily for every request, it raises a single HTTP event like this. But if the response is too slow, then it also raises this slow HTTP event. And so in this case, we say we have a single event, and in this case, we have a first event and a second event. And the reason for this assertAll here is that our latency will be different between different runs of tests. So we can't just create an instance of HTTP event with a particular latency inside it and show that's what we get out. So instead, we have a multiple series of asserts here. And what we wanted was, even if the first one failed, we saw that the other ones had passed. So we could say, if we ran that and made it fail, that we'd see this failure, but these other tests would have been run. Ordinarily in JUnit, we wouldn't have tried to do these, but because this is assertAll, we know that this one failed, but this one passed and this one passed. One of the ways in which we kept on messing it up was that we would be comparing this OK, which is class, with this status, which is an int. And if we run that, you can see we get two failures, one for the root and one for the status, and both are reported by JUnit. It would be nicer if this didn't compile. It does compile because in JUnit, assertEquals is defined on object and object. This status here will have been autoboxed and we'll be comparing it to this object, but we can do better. We can get the behavior we want by the Kotlin test library provided by IntelliJ. So in our Gradle file, we'll include test implementation. We need org JetBrains Kotlin test. Import that. And now if instead of importing the Jupyter version from JUnit, we import kotlin.test.assertEquals. Now you'll see that this one doesn't compile. So we need to add OK.code to get it to compile. Fix that, run our tests. Good. And if we drill down into these, you see there's this asserter, and this asserter is implemented by JUnit when we're running with JUnit. So we're actually running the same code in the end, just with better type safety. Okay, let's have another look at the message when this fails. So we'll make it fail again and run. Now you see here we've got the single failure. I'm going to report down here that shows that we could have had multiple failures but only had one, and shows what went wrong. What it doesn't show is the whole object, and really we're interested in a single object here. So we can fix that by using this, which in this case is the single event, toString, as the message parameter, I think it is, heading to assertAll. If we do that and run, then after the detail, we are showing what the whole HTTP event is, which if we're trying to diagnose this problem on a CI server or somewhere like that would be very useful. In fact, this pattern of making multiple assertions on a single object is so useful that it's worth writing our own little function for. So what we'd like is a function that's defined for some t and is assertAll, and that takes a subject, which is of that type, and some assertions. And for now, we'll say that it's a list. And what's it a list of? Well, here, this is our subject. It's this event. So what we want in here is something that is an extension on t with no other parameters and returns unit. Now the whole of this thing is going to return unit because it's going to throw if everything goes wrong. Now in here we can make our subject this with a with, and then use the JUnit assertAll with our toString as a message. And now we need some assertions. The problem is that in this assertAll, these are executables, which is something to unit, not an extension on a t to unit. So let's go back and say, if this was converted assertions, and we had a local variable, well, that can't be null. What we know is that its type has to be a list of something that takes nothing and returns unit. And for now, we'll just say to check that compiles. Okay, how would we convert assertions into converted assertions? Well, we're going to want them to be one-to-one, which means we're going to take our assertions and we're going to map. And in here, we need to return a lambda that takes nothing and returns nothing. So in fact, an empty lambda would compile. We don't want an empty lambda, though. We want to use it, the assertion in here. How do we use the assertion? Well, if we just invoke it in this lambda, then it will pick the this from the with. So that will be this dot assertion, which is our t here. So we can get rid of that and try it out. So in here, let's just duplicate this one. And this is going to be, take that and put it into there. And for now, we've got list of, we'll fix that in a minute, our assertions. Get rid of you and reformat. Let's see if that works. We've still got a failing test at the top. So let's fix that. But you can see that our slow transactions at least passes that way. Let's see what happens when it fails. Let's change this one to be forbidden and run. And now this one has our assertion failed. But when we look in the detail, it says this is the whole object that we got, and this is the part that wasn't right. We can finally tidy up a bit by having a version of this with the var args. So we'll say, duplicate that, make this var arg assertions, then it's not a list, but it is assertAll, subject, assertions to list. And in fact, I think this could be iterable. And that allows us to get rid of our list of here for a nice little test utility. That's what it looks like when it fails. And when it passes, everything's good. I'll just go off and convert our other uses. For example, this into there, that. Ah, that was already a duplicate, so we can get rid of that. I'll do the same here. In here, and run. Good. I think these would be quite good moved out. So we'll say we'll take that and that into rows testing And maybe we'll call this asserting. And I'll commit that while you go and put the kettle on. Of course, we haven't invented this idea of multiple certs with single subject. Nat Price wrote Hamkrest to integrate with JUnit in Java, and has since written Hamkrest with a K for Kotlin. So let's try converting one of these to Hamkrest. We already have Hamkrest as part of HTTP4K testing, so we can take this, for example, and use assert that. Now let's work our way up. What we're going to do is we're going to comment these out for now, and events1 is our subject. And the first thing we can do is say that that is and that's a matcher, slow HTTP event. That would be true and not interesting, so let's just see what happens if we make it fail by making that an HTTP event. And run that. So assert that has thrown an assertion error, and the message is expected a value that is an HTTP event, but actually it was a slow HTTP event. Okay, so we can fix that back to slow HTTP event. And then inside here we can add another matcher, and that matcher will be a matcher on slow HTTP event. And there's a matcher for properties, which is has. And so we can say that has a property of slow HTTP event URI. And then that takes another matcher, which in this case is going to be equal to slash. And now let's run that. Well, that was true, so it succeeds. And if we make it fail, now we get a message saying we expected a value that is slow HTTP event and has a URI that's equal to this, but the URI wasn't that. Okay, this is a single matcher, but we can combine them. So we can say it has that and has slow HTTP event method equal to get. And I'll leave out the toString for now, so we can see what happens if we get multiple failures. So I'll run that. Okay, we can see this failed, but it only reports the first failure. If we were to make the first one pass, then we see the second one does fail. So and is sort of short-circuiting, which is a little bit unsatisfactory, but never mind, we can add the final one in, which is that our status is okay code. And if we fix that up to be get toString, then that should pass. Okay. Now, as you can see, ands are a little bit unsatisfactory when it comes to formatting. So there is an all of. We remove that, and import all of. And again, if we make two fail though, you'll see that all of really just uses and only reports the first failure. Another issue with Hamkrest is this oddness with isa, where the compiler's type inference knows because we're using has here that this is a slow HTTP event, so it suggests you remove this, which you can do, but isa was communicating to us the type of event. It's a bit unsatisfactory. Another unsatisfactoriness is that this has compiled. So we lose the type safety here between the type of this property and the type of this matcher. These irritations with Hamkrest sort of add up over time. If you're a Java developer and you had to make Hamkrest with a C work for you, then Hamkrest with a K is a good option. And support for it is built into HTTP4K's testing, but I'm not really sure I'd recommend it as the go-to structured assertions library. So what would I recommend? Well, let's have a look at Strikt. We're going to import Strikt with test implementation IO Strikt core, and the current version is 0.34.1. Refresh that. Now Strikt starts with expect that, and again takes a subject, so we can say events 1, and it also has an isa. But note this chains. So that's isa slow HTTP event, and let's run that. What it passes, what if it doesn't? And here you can see that Strikt gives us a nice text representation, showing the subject, showing what we asked about it, and what wasn't true. If we return this to the right type, then we can chain. So we can say get, passing that slow HTTP event URI, and make assertions on that. And if we get that wrong, then run. Do you see here we get a nice little diagnostic telling us that we checked it was a slow HTTP event, but the URI was wrong. If we carry on chaining, then we could assert other things about this URI, but we don't want to do that. We want to assert other things about this event. So instead we can say and in here we can put a bunch of assertions. So we can say the URI and the method get. Note this is type safe, so that we have to say get to string, and we can do the same for status. And I'll just use forbidden so you can see what happens when two things are wrong. And here you can see again, we're told the whole object we were testing and that the URI was wrong and the status was wrong. And down here, a summary that shows the things that were right and wrong. So ticks, crosses, ticks, crosses. This is really helpful. Rob Fletcher has done a really good job here. He's done such a good job, in fact, that we can assert about a whole collection. So we've got events 1 and events first. So let's copy this, put it down here. And now we can say expect that events has size 2 with first, and that is a HTTP event. And well, it's this set here. If I fix that, it's going to be very much like that, where these are all HTTP event. And with element at 1, and that is this. Reformat, say if we're right, and run that. Now, because we've left the space in here, you can see how it fails. And here's our whole collection. It says the first element should have been like this, but was like this. Second element should have been like this, but was like this. Fix that up. And that passes. So on the whole, that's good enough that I think we can get rid of this. And the Hamkrest version, leaving us this version for our slow one. And for the single event, we can say events has size 1 with first. And run. Brilliant. Let's check that in. And if anyone knows how to get rid of this deprecation, I would be very grateful. Commit anyway. These strict assertions not only read very well in tests, they read very well when they fail. I should say, though, that there's another solution to the problem, which is even simpler. What we can do is we can build a list of the events that we expect, ignoring the latency. So that is a list of, first of all, an HTTP event with a slash, get to string, OK code, and let's say 0 for latency. And then we've got a slow HTTP event with the same parameters. Now we can take our events without latency, which is events map it with latency 0. And then just assert equals expected events at latency. Remove these. Now we have a bit of a problem because it with latency 0 doesn't exist, but we can make one of those. And this will just say, when this is an HTTP event, it's this copy latency is 0. When it's a slow HTTP event, it's the same thing. Otherwise, well, we didn't know what we had in our list. Run that. That passes as we expect. And if we were to make it fail in some way, then we get a normal JUnit failure report, where we'd have to scroll left and right in order to see what the issue is. and have it hidden here probably around the space. But for cheap and cheerful, that's quite a useful technique. On the whole though, I think I prefer the strict version, so let's back that out. And I think we're done for the day. Thank you to everyone who helped in the comments in the last video. There's a concurrency error in our current tests. It's a little subtle and I don't expect it to do any harm, but I'm offering a prize to anyone who identifies the issue. So let me know in the comments to this or preferably the last video. And next week we'll see if anyone found it and work out how to fix it. If you'd like to see that episode, then please subscribe. And if you've enjoyed this, then I think you'll enjoy the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.